Okay, so I wanted to show you an example of the scale factor room project. And the first thing you need to do is choose a room. What we're doing here is we're taking an actual size room and then we're creating a blueprint like what you see here on the screen of the room that you choose. Okay, so it's going to be different for everybody. You can pick any room. Probably helps to pick one that's a moderate to a little bit bigger size room. But any room will work, and we're going to draw a scale size, a blueprint of this, kind of like what you see. Builders, architects will draw a blueprint of a building, could be a room, a house, something that's going to be constructed prior to building it, and it's like an exact proportional design of what's going to be built, and then that's what's used by the people and the companies that go in and get something built and constructed, like building a real room. So we're kind of working backwards. We're making the blueprint, okay? So the first thing you need to do is choose a room. Choose any room you would like. You just need basically two measurements. You need a length and a width measurement of your room. And in the example I'm going to do, you'll see that I get a couple more measurements than that. I have a couple of length and width. But it's because the room I use, which is going to be the math classroom, has a section where the front door is, or the door to enter the classroom is, that kind of sticks out, and so it gives us kind of an extra length and width on one of the ends, okay? So you're going to choose a room, and you got to measure. We need to measure a length and a width, and I don't have a picture of the full math room, but you can see right here I had a yardstick, a ruler, tape measure. These are all great for measuring. If you have access to any of these in your home, that's great. Remember, a ruler is 1 foot. A yardstick is 3 feet if you have that. And then a tape measure is great because you can probably measure the whole room just by dragging the whole tape measure across the length and the width, okay? So doing it that way, always start at one end. Make sure you go all the way across as straight as you can to get an exact measurement of the length and the width of the room you choose. Now, if you don't have access to a ruler or a yardstick or a tape measure or anything that can measure, you can always use a sheet of paper. I do this sometimes. A regular notebook sheet of paper is 8.5 inches wide and 11 inches long or tall. So that's the part you can focus on. You can basically almost round out this notebook sheet of paper with the 11 inches here to 1 foot. It's pretty close. So you can kind of estimate that, hey, this is pretty close to 12 inches, which is 1 foot. If you have a computer piece of paper, printer paper, they're a lot closer to exactly almost 12 inches long, which is also 1 foot. So if you don't have a ruler or a tape measure or yardstick, no problem, don't worry about it. Grab a sheet of paper and just use that, basically about 1 foot long, and that will work for what we're doing, okay? So I got the measurements of the room, the math room, and a couple of quick measurements. The two I'm going to start with, it had a basic width of 29 feet, it's a big room, and then a length of 35 feet. So after you measure, you got to decide what the scale is going to be. Okay, we're going to take a big room and we're going to draw it on a sheet of paper, which means we are shrinking it down, we are reducing it. So each of these units, you need like this is why we're going to use Google Slides or something with like a graph, a grid on it, because each of these units is going to stand for a certain amount of feet on the drawing, and it can't stand for one. It needs to stand for a number other than one. You can't do 1 unit equals 1 foot. Not letting you do that. We need an actual scale so we can do that. So what we're going to do, in my example anyways, I chose that 1 unit, one of these units on the grid that I'm moving around accidentally, is going to be equal to 2.5 feet, 2.5 feet. You could do 1 unit equals 3 feet if you want, or 1 unit equals 1.5 feet if you want, or 1 unit equals 4 feet. Any of those will work, but don't use 1 unit equals 2.5 feet, because I already took that one. I'm doing it right now. So what does that mean, gentlemen? Well, that means if I told you earlier that I had a width of 29 feet, I need to figure out how many units that would actually be. So I use my scale factor as a proportion. Okay, write it like this. 1 unit is equal to 2.5 feet. And I made this scale up myself, you're going to make yours up yourself, and then you're going to apply the math. Okay, but what if I have a width of 29 feet? Got to figure out how many units that would be. So what I'm doing here is finding the proportional relationship. I got to divide 29 by 2.5 because I don't actually know off the top of my head how many times 2.5 goes into 29. Decimal goes over, and we come in and we divide here. Now I'll tell you real quick, 25 is not going to go in there. It'll go in 1, 1. It's going to be about 11.6 units, okay? So what that means is when I draw my first width, and my width is going to kind of go this way, and you'll see on my next screen, I'm going to go 11.6 units for my width. And there it is. And I put 29 feet. Now you'll see too, I'm even a little bit short, and I'll fix that on one of the slides coming up. But you can always kind of modify it as you're working, and it gets a little bit tricky when it's small, but try to be as exact as you can because that's important with our proportions and our scale factor, okay? Now I need to do the length. The length, when I measured it, was 35 feet, okay? So 1 unit, I'm going to go back to my scale. 1 unit equals 2.5 feet. Better get the decimal in there. Super important. Okay, well, what if this is 35 feet? Okay, gotta find the proportional relationship in there. Gotta take 35 and divide it by 2.5, just like that. 0.0 there. And see what we get. Now, I know after you divide this in, it's gonna go 0 there, 1 there. It's gonna be 14.0 or 14 units, okay? So I'm gonna go in with my length, and I'm going to make it 14 units long. And you'll see if I count them, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14. It's 14 long. I put 35 feet there. And I'm on my way to getting this thing blueprinted out here proportionally. Okay, so I'm going to continue with that. I had another width. I told you I had 2 different widths, and it's kind of the way the door is in the classroom is a little weird. So most of you will just have 1 length and 1 width. I have 2 of them, so I went ahead and tried to be as exact as I could. It was 26.5 feet. I had to convert it to 10.6 units, 10.6 units. Then coming down this way on the width, when I got it, I got that together. It was 30 feet, which was, I believe, 12 units long. And then from there, the door section was a little bit tricky on my math classroom because this is kind of where the door is over in this section right over here. And it's got this part that kind of sticks out. So I had to measure that. It was 2.5 by 5 feet. So you'll see where I measured that in there. I got my units converted. I put my feet in there. And I started just kind of putting it all together. The next thing you want to do is write in how many units. So I put the feet in there. You see where I had 29 feet, 35 feet, 26.5 feet, 30 feet, 2.5 feet, and 5 feet. Also want to include the units. How many units does that basically proportionally convert over to? Okay, well, 11.6 units. And this is where I fixed it right there. 14 units, 10.6 units, 12 units, a unit there, and then 2 units there. So basically what I've done here is I've done, I think, a pretty solid job of coming up with the initial blueprint for the math classroom, okay? All the measurements, it's to scale. It should be proportionally exactly the same as the actual math classroom that I measured, okay? The next thing you're going to do is you need the 3 items. The 3 items in the room, and again, you want them to be bigger items, larger items, basically things that kind of stay in the same place most of the time, furniture style items. And I had some things circled already, but you see here, I picked 2 bookshelves. I have a bookshelf in the back corner, one behind the desk, and then I picked a desk, okay? And these were tricky to measure, so you might pick some things that are a little bit larger because they're easier to measure and usually easier to convert, okay? I'm just putting a warning out there. Don't pick a super small table. That might be kind of tricky. Pick something a little bit larger. Make your life easier on this one, okay? So I picked some small stuff. My life was not easy on this one. And you'll see I forgot to type in some answers, so I'm going to have to fix them in just a second. But I'll show you what I did. I moved over to the right side of the grid and kind of laid out the 2 bookshelves and the desk and put the units down, okay? So when I measured them, the 2 bookshelves are actually 3 feet long by 1 foot, and I'm going to switch to green, by 1 foot wide, and I mislabeled them. You'll see in the next slide. I copy and pasted one and forgot to edit it. So they're 3 feet by 1 foot wide, I'm sorry. And then the large desk that I sit at is 5 feet by 2.5 feet wide. You need to convert them. I had to convert these here, okay? So again, I still used my scale. 1 unit was equivalent to 2.5 feet, just like that. So if I have 1 foot right here, I got to convert 1 foot. That's real tricky. 2.5 goes into 1. A lot of students would tell me, no, it doesn't. It doesn't. It does. It can work out. You're going to get a decimal. I got a decimal. I had to do 1.0 divided by 2.5. Decimal over there. And in dividing this, 25 doesn't go into 1. It doesn't go into 10 either. Remember that you can drop a 0 in. 25 goes into 100 4 times. So it's 0.4 should be the units. What does that mean? 0.4 units. And they were both the same size. So that was cool. So I kind of only had to do that 1 time. So that was the idea right there with my 2 bookshelves. So you'll see if you look at my bookshelves, they're really narrow right here. They're only 0.4 wide, and they're 1.2 units long, so just over 1 unit long, both of them, to kind of fit in and get their space. I then did the desk. The desk was 5 feet by 2.5 feet. You'll see here where I did that, and you can kind of see where I mismarked some numbers. But the desk is correct here. It's 5 feet by 2.5 feet. It's 2 units by 1 unit, which you'll see I did there. And then going back, this is the correct way for me to at least mark the bookshelves. I have them, they're proportionally measured here. I just didn't get my right units changed over like I did here. Okay, so 1 foot. So that's the idea there. I basically have it all done. In my final image, I just put some arrows to kind of show where each of the items go, the furniture and such. And I have everything converted. I have a scale factor. I have all the measurements and feet and units for my whole room. I've got them for my 3 items. And it looks like I've been able to get through this. So you're going to do the same thing. Pick a room, get the measurements, make sure you have your 3 items. Again, I would pick some larger items. I think that'll make it easier for you. Pick a scale factor too that you think will work out. 1 unit equals maybe 4 feet or 1.5 feet, something like that. It can't be 1 foot, but not too large. I wouldn't put 1 unit equals 10 feet or anything like that. You're going to end up with a really tiny drawing. But this is the gist of the project we're going to be working on. So good luck with it, everybody.